Good evening, class. In the series of Fundamental of Maths, we had already discussed about the area of triangle, the collinearity, and today we will be discussing about one of the major topics of this. So today we'll be discussing about the internal division. The internal division is that when a line segment it is bisected by a particular line, it is cutting that line into two parts. That is, we can say that we can consider it the ratio will be m is to n. It is internally when the line segment it is bisected by a line part which is different from the end of across it, then we can say it is an external bisection. Now, as of now, we will be discussing about the internal bisection of a particular line, and later on, we will be discussing about the external bisection also. So, in this case, earlier we had described about the area of triangle. So, today we will be considering about the internal division of a particular line. So, suppose this internal division of a particular line, we are deriving from the concept of the coordinate geometry. So there are certain coordinates are there which we had predefined, which we had entitled earlier. The coordinate, that this is a line segment which is bearing the title of PQ. That is the line segment, and P is having the coordinate of x1, y1. R is the point of you can say R is the second point that is having the coordinate of xy, and third coordinate is Q that is having the coordinate of x2 and y2. Okay, so suppose if we will take the coordinate of this point, this is the point S and point T. From the point R we are dropping two from R we are dropping one perpendicular, that is RS, and the second perpendicular is from the point Q, that is QT and RS. So we will be discussing about how the coordinate differs, how we are taking the coordinates, as we had already studied in the coordinate geometry in the very first class of the fundamentals of basics of maths. We had already discussed about the coordinate geometry, the location of a particular point in the space. So in this case, we will be using that concept only. You will be using that fundamentals only so as to derive the location of a particular point. P is having the coordinate of x1, y1. R is already, we are assuming that R will be having the coordinates of xy, and this one, and this Q is having the coordinate of x2, y2. So we will be checking here. Suppose this is the particular distance y1, and this is the particular distance y. This is the y, this is the perpendicular distance from R. So total length of this RS will be y, and this is y1, this is y1, this point is y1. So this particular distance will be y minus y1. This one is y minus y1. Similarly, this particular point y2, it is the coordinate of Q in the y-axis. So it is total distance is y2 from this point to this point, this axis, and this is y. So this distance will be y2 minus y. Similarly, we are taking the x coordinate. We will be taking the x coordinate. This is the x-axis and this is the y-axis. So we will be taking this x-axis now. So in the x-axis, we will be defining the location of a particular point. So this point is x, and this point is you can say this point is x, and this point is x1. So this particular distance, it will be x minus x1. Similarly, this particular point R2 will be, this is total distance is x2, this is x. So this distance, it will be R2 will be x2 minus x. Now we had already studied in our lower classes that using the concept of similarity, we have to prove that both these two triangles, both post construction, the triangles which formed, which are entitled as PRS, this triangle, this one triangle, and QRT, this triangle. So we have to prove that these two triangles are similar. Triangle PRS will be similar to triangle QRT. So we will be using the concept of AA similarity, in which the two angles will be similar. So if in two triangles, if two angles are similar to each other, then automatically the third angle will be similar. So using that concept we will be applying here. So see this axis, this angle RPS will be equal to angle QRT. This is perpendicular, so automatically this angle will be equal to 90 and this angle will be also equal to 90. So angle RSP is equal to QTR. This is also 90, this is also 90. This angle is equal to this angle. So two angles of a particular triangle is equal to two angles of another triangle. So automatically the third angle will be equal to that also. So the third angle will be this angle. This angle will be, now the third angle will be, this angle will be equal to this angle. Now, so we will be using one nomenclature like this. So it will be easy for us to define which angle is equal to which angle. So now we will be using the concept of the angles are equal now. The side opposite to angle will also be similar. So the side opposite to this angle, that is RS, the side opposite to this angle is QT. So RS by QT is equal to this angle. This angle is equal to this angle. So side opposite to this angle, that is PS by side opposite to this RT. So PS by RT is equal to PR by QR. So this is the angle theorem, that is the side opposite to the angles, or the angles opposite to the equal sides are, the angle opposite to the similar angles are similar. The ratio of that will be similar. So we will be substituting the values, the respective values of the line segments here, and we will be drawing one conclusion that this is the particular ratio. We had already defined this is the M and this is the M. So total ratio it is M is to N. So we will be defining here M is to N is equal to the distance, that is RS by QT. RS is RS. If we are taking x1, so we will have to take that PS by RT. So what will be the PS? That will be x minus x1. That is the PS, x minus x1. And what will be the RT? RT will be x2 minus x. So here after substitution we are getting M by N is equal to x minus x1 by x2 minus x. Now we will be cross multiplying. We will be doing cross multiplication. So after doing the cross multiplication, we are getting mx2 minus mx is equal to nx minus nx1, and mx2, the like terms, we will be taking the like terms to one side. We will be taking the like terms to one side. That is mx2 plus nx1 is equal to x will be outside, n plus m. So after doing all these things, we are coming to one conclusion that x, this point, the x coordinate of this point will be equal to mx2 plus nx1 by m plus 1. This is the basic formula, and this is very important formula used in the field of coordinate geometry. So this type of bisection is defined as internal bisection, where a particular part, suppose this is a line segment. Suppose this is a line segment which divides this particular segment into two halves, and these two halves is bisected internally. So this is known as the internal bisection. And external bisection is, suppose this is the particular line segment is there, and if a particular line segment, if it is falling here, if it is dividing the line segment after this particular segment PQ, then we can say that will be known as the external bisection. That we can say that will be known as the external bisection. So this is the basic formula which we are using to solve a particular problem, which we will be using to solve the problem for the internal formula. So we will be taking one example. Thereafter it will be clear how we will be applying the formula in the coming future. So we had already derived one formula that x coordinate of a particular point will be x is equal to mx2 plus nx1 by m plus n. Similarly, y will be equal to my2 plus ny1 by m plus n. So we will be writing that formula: x is equal to mx2 plus nx1 by m plus n, and y is equal to my2 plus ny1 by m plus n. So in this internal division, we will be getting different types of numericals. The first type will be where we have to calculate the ratio, where we have to calculate the ratio in which a particular line segment divides the another line segment. Secondly, we will be second type will be in that case we have to find the coordinates of the middle point or the third point. So these are some of the types which we will be getting in this particular internal division formula. Suppose this is a particular line segment which is having the point R is there, and the coordinates of R will be xy. P is the coordinate, P and Q is there. P is having the coordinate 0, 0, origin is there, and Q is having the coordinates 2, 0. Suppose it is 2, 0. And we have to calculate the ratio, and the xy, it is also given at xy, you just say it is 1, 0. That is, the coordinate of point R is 1, 0. And we have to calculate the ratio in which a particular line segment it is divided. So in this type of numerical, we will be taking the ratio as k is to 1. The ratio of internal division will be k is to 1. So we will be applying the formula x is equal to mx2. M is k x2. x2 it is 2 plus 1 into 0 plus nx1. nx1 will be mx2 plus nx1 by m plus n. That is k plus 1. That is, and secondly, y is equal to my2. M is k y2. It is 0 plus n. N is 1 into y1 0 by m plus n. That is k plus 1. Understood? So this is the particular formula which we will be using, and after that we will be solving it. The coordinate of x is given 1. So we will be using 1 is equal to 2k plus 0 by k plus 1, and regarding this, y is already 0, so it will be 0. So it will be, after solving, the final answer which we will be getting here, k plus 1 is equal to 2k and 1 is equal to k. Therefore ratio will be equal to 1 is to 1. Ratio will be equal to 1 is to 1. So this particular point R divides this line segment in the ratio of 1 is to 1. So this is one of the simple numerical of one type in which we are calculating the ratio. Second type is that the ratio will be given and we have to calculate the coordinate of that particular point which divides the line segment PQ. So these are certain types which we will be seeing in the next class also. So as of now, I had discussed the one part of this internal division. In the next class, we will be continuing this topic only. So please see the video, like it, subscribe it, and if possible, if you have any doubt, please do comment on the comment box so that I will be getting an intimation that which type of problem you are facing as of now, and in the next class I will try my best so as to resolve that issue. Thanking you. Good night.